This is the tech team for Ereckson Robotics, which is comprised of Arista Barwaj, Kate Ling, Siddharth Kulkarni, Arnav Bansal, Arnav Pradesai, and Ishant Bankapur.
For the final program, we programmed our robot using Simulink, a product of MATLAB. Simulink is a flowchart-based graphical programming environment with drag-and-drop blocks. It roughly translates to other languages such as C or C++. For the basic driver movement, all of it is limited to the left joystick to reduce the number of buttons pressed. An arcade module is used for simplicity of controls for driving. Some blocks have been added to attach precision control and autonomous to the arcade module. Precision code, the 8 up, down, left, and right buttons are used to navigate precision control. The precision state flow inputs into the sum blocks, which connect to the basic driver movement and motors. Put simply, precision is a variation of basic driver movement, but the voltage is limited to 55. Adjusting positive and negative values is useful for turning and moving backwards/forwards. All of the autonomous code is using the 7 up and down buttons. The 7 up button is for canceling autonomous if activated on accident. The 7 down is for the activation of the actual autonomous code. Autonomous also connects to the sum blocks for the basic driver movement. The autonomous state flow works when we press the 7 down button, the autonomous subprocess starts. The robot drives into the zone, turns 180 degrees, and drives back out. This action can be stopped at any time by pressing the button 7 up.
This is the code for the arm. The value output increases as the joystick is pushed up and decreases when pushed down. The -1 gains to flip the values, such as making a positive output a negative value and a negative output a positive value. This is the code for our rack and pinion. The latch between the state flow and the button is there to retain the value the button sends when pushed once. If you push the button, the value sent is 1, and if you press it again, it will be 0. When the button is pushed for the first time, it sends a voltage of -120 to the servo. This closes our forklift arm and it will only open and reset to 0 when the button is pushed again. This is designed as a toggle system. The light bulb barrel is controlled with the 6 up and down buttons and are connected to the motor with a sum block. The 6 down button sends a negative value because of the sum block, and the 39 gain multiplies the input from the sum block since the incoming value is 1. To conclude, this is how our program for the game functions. Thank you for viewing our Simulink design for the Best 2021 competition. Make sure to support Ereckson this year.